Good morning, guys. I hope you had a lovely half term and welcome back. If you haven't done so already, please complete the retrieval quiz on your Google worksheet, pause the video, come back for your answers. Okay, so let's go through our answers. Make sure that you are making self-corrections. This is instant feedback, so any mistakes that you've made, it is important to correct them and therefore learn from them. So if we add iron-free ions in a precipitate, it would form orange-brown colour. Copper-2 ions produce a blue precipitate. The solution used to test for metal ions is sodium hydroxide. The metal ion that dissolves in excess sodium hydroxide solution is aluminium ion, which is Al3+. Number 5, we can use a flame test. Number 6, if a green precipitate forms when sodium hydroxide is added, we know that it must contain iron 2 ions, Fe2+ or +2. Number 7, if we get a green flame during a flame test, it must have copper ions in it. Number 8, the part of the flame test that helps clean the wire loop is dipping it in acid. There should be a G on the end of dipping it. Number 9, it is difficult to use a flame test on a sample with 2 metal ions in because the 2 colours might mix or the colours are masked. And for the challenge, describe what happens during a precipitation reaction. Well, a precipitate is a solid, so a precipitation reaction is when 2 solutions are mixed and they react to form a solid. Okay, so today we're looking at how to test for negative ions. We've looked at how to test for positive ions using flame tests and how to use sodium hydroxide solution to test for positive ions. And today you need to be able to describe how to test for and identify non-metal ions. Now, non-metal ions are always negative ions. So we're looking at the test used to show the presence of negative ions. So 3 keywords. A negative ion forms when an atom has gained electrons. If it gains electrons, it becomes negatively charged. A precipitate is a solid formed during a chemical reaction. And insoluble, you should know that insoluble means it does not dissolve. So just to quickly recap, but pre-half term, before half term, we started this topic on chemical analysis, how we can analyze different substances, we can test different substances to find out what components are inside of them, what elements and compounds make them. So we've looked at chromatography and how to separate a soluble mixture using chromatography. We've looked at ions and how to test for positive ions, and now we're looking at how to test for negative ions. So just like we looked at for testing for positive ions, I just want to quickly go through what ions are and how negative ions form. So remember, ions form when atoms lose or gain electrons. An ion is a charged particle. So an atom is neutral. If it loses electrons, it becomes positive. We looked at that already. So now we're looking at when an atom gains electrons, it becomes a negative ion, an anion. And we remember negative ions being anions because it sounds like onions, and onions make you cry. Now, just to go through a few examples of anions. Chloride ion, Cl minus. Bromide ion, Br minus. Iodide ion, I minus. Now, what you'll notice is that all of these ions form from group 7 elements. If you look on your periodic tables in your planners, these are all ions formed from group 7 elements. Now remember, if they're in group 7, they all have 7 electrons on their outer shell. They gain an electron to form a full outer shell, and that's why they become negative by 1. And remember, the periodic table can show us what ions each element will form. Now we're focusing on the negative ions today, so group 7 atoms always form -1 ions. Group 6 always form -2, and group 5 form -3. Now, you do need to understand that group 7 ions are referred to as halide ions because they come from group 7 atoms, which are called the halogens. So any ion formed from an element from group 7 is called a halide ion. So for example, I know fluoride would be a halide ion because it's formed from fluorine, which is in group 7. Now, some other negative ions you might be aware of are oxide ions formed from oxygen atoms. Now, oxygen is in group 6. It's in group 6, it gains 2 electrons. It becomes O2 minus, or O minus 2. It's got -2. It's got a charge of -2. Now, you should notice this ion, OH minus, hydroxide ion. Well done. Now, some other negative ions you need to be aware of is CO3, -2. Now, that is what we call a carbonate ion, and SO4, -2. And that is what we call a sulfate ion. Now, what you'll notice about these negative ions is that they are all non-metals. So you've got your halide ions, you've got your carbonates, and you've got your sulfate ion. So you need to be able to describe the tests and the positive results for each of these ions. Sulfate ion, SO4, -2. Carbonate ion, CO3, -2. And the three halide ions, chloride, bromide, and iodide, formed from chlorine, bromine, and iodine. So the first test we're going to look at is how to identify for carbonate ions. So the first step you need to do when looking to see if a substance contains carbonate ions is to add acid to the unknown substance, to the unknown compound that you are testing. So you add the powder into a test tube, you add some acid. If it's a carbonate, what you should see is bubbling, you should see it fizzing, because carbon dioxide gas should be being produced. If you bubble that gas through lime water, the lime water should turn cloudy. So to find out if a substance contains carbonate ions, you add acid, you bubble the gas produced through lime water, and the lime water turns from colourless to cloudy. And you should have seen this at some point through your school years in secondary. You can do this with a straw. You can blow through lime water, and because the gas you're exhaling is carbon dioxide, you'll see it go from colourless to cloudy. So to test for carbonate ions, you add acid, you collect the gas and bubble it through lime water. If it's carbon dioxide gas, it will turn from colourless to cloudy. So what I'd like you to do is watch the video on your student worksheet for task 1, and then come back once you've done that. So pause this lesson video, go and follow this link, and come back once you've completed it. Okay, So that takes us on to identifying for the next negative ion, which is sulfate. Sulfate ions. SO4 minus -2. So in order to test for sulfate ions, you've got an unknown compound, an unknown substance. Firstly, you add a few drops of acid. Now, that step isn't really important. It is only to get rid of any carbonate ions. So we don't want any carbonate ions when we're testing for sulfate ions because it might give us false results. So we add acid to get rid of any carbonate ions. Once we've done that step, we can then add the important solution of barium chloride. Now, barium chloride is the substance used to test for sulfate ions. Now, if sulfate ions are present in the solution, you will see a white precipitate formed. Now, the reason you get a white precipitate when you add barium chloride to sulfate is because the sulfate ions will react with the barium, so it actually forms barium sulfate, and the barium sulfate is an insoluble precipitate, which is white in colour. So you've got your unknown solution, your unknown compound. You want to know if it contains sulfate ions. You add barium chloride, and you should see a white precipitate formed. That white precipitate is barium sulfate, which is showing me there is sulfate present. And the word equations show that reaction. You're adding barium chloride to a sulfate. In this instance, we're going to use sodium sulfate. So barium chloride plus sodium sulfate forms barium sulfate and sodium chloride. Now, the barium sulfate is the white precipitate, the white solid formed in the solution, and the sodium chloride stays in the solution. Now, barium sulfate, because it's insoluble, does have some uses. Now, a use of barium sulfate is if somebody's got problems with their digestive system, because the digestive system is made up of tissue and not bone, it doesn't show up very well on x-rays. So what they do is they'll give you what they call a barium sulfate meal or a barium sulfate drink. You drink that. As it passes through your digestive system, it will show up on an x-ray because it's an insoluble solid. But it is safe to drink because it's insoluble. It doesn't get dissolved and absorbed by our digestive system. So as it passes through, an x-ray can be taken and any blockages or any problems will show up. Hey, magic or science. Woo! So task 2 on your student worksheet, I would like you to follow the link for the video on testing for sulfate ions. Once you've done that, come back to the lesson video. Okay, so that leads us on to the final negative ion tests, which are testing to identify if a compound contains halide ions. And remember, halide ions are any ions formed from group 7 elements. So the ions we're going to be looking at are chloride, bromide, and iodide. So in order to test for halide ions, firstly you add a few drops of nitric acid. Now all that step is just to get rid of any carbonate ions, so it doesn't impact on our results. We don't want our results give our results false and inaccurate. So we add a few drops of nitric acid to get rid of any carbonate ions that might be present. Once we've got rid of the carbonate ions, if there were any present, we can then test for halide ions. Now we add silver nitrate to the sample. So just like we used barium chloride to test for sulfate ions, to test for halide ions, we use silver nitrate. And then you need to observe, you need to look for a precipitate forming. Now remember, a precipitate is a solid forming when two solutions are added together. So if you look on the screen at the image, you can see that AgNO3 silver nitrate solution is being added to the sample. Now, if the sample contains chloride ions, you get a white precipitate forming. Now, that white precipitate, that solid insoluble precipitate that forms, is actually silver chloride, and that's how we know it contains chloride ions. So if it's a white precipitate, it shows chloride ions. If, when you add silver nitrate, it forms a cream precipitate, we know it contains bromide ions because silver bromide has got a cream colour. Now, if it gives a yellow precipitate, so a precipitate that's darker in colour again, it shows the presence of iodide ions. So silver nitrate, so if we had silver nitrate and we were adding it to a sample of potassium chloride, now look at that, potassium chloride must contain chloride ions. Now when we add the silver nitrate, the chloride ions react with the silver in the silver nitrate to form silver chloride, and the silver chloride is the insoluble precipitate that forms. Now, if we had silver nitrate and we added it to potassium bromide, the bromide ion would react with the silver and it would form silver bromide, which is our solid precipitate. And if it's bromide, it must be cream coloured precipitate. So watch the video on testing for halide ions. You only need to watch the first 50 seconds. Okay, so follow the link for task 3 and watch the first 50 seconds for this lesson, for this video. Come back once you've completed that task. Okay, so moving on, leads us on to task 4. So task 4 is all about your knowledge on negative ions. So summarising what we've learned this lesson. So the first table, name these halide ions. Now remember, halide means it's a halogen. It's come from a group 7 element. So you've got the formulas Cl minus, Br minus, I minus. I need you to name them. Then name the following ions in the next table. They are the polyatomic ions, the ions made of more than one ion, one element in an polyion. Now, you should know the first one, OH minus, CO3 2 minus, SO4 2 minus. So you need to name those polyatomic ions. So poly meaning many, atomic meaning atoms. So it's more than one atom in that ion. And then what you need to do is complete the following sentences. So there's a description of each negative ion test. You need to complete the sentences. There's obviously a typo at the end of the last one, as it says at. That is a typo. I don't know why it's there. So ignore that, please. It shouldn't be on your student worksheet. Now, pause the video, come back once you have completed that. Okay, so the answers are as follows. Cl minus, chloride, bromide and iodide, hydroxide, carbonate and sulfate. Now, to test for a carbonate ion, you can add acid, bubble the gas through lime water, and the lime water goes cloudy. Sulfate ion, add the acid to get rid of the carbonate, and then you add your barium chloride. If a white precipitate forms, then a sulfate ion is present. Add nitric acid. For your halide ions, you add nitric acid and silver nitrate. You get a white precipitate for a chloride ion, cream for bromide, yellow for iodide. So well done if you got those correct. That leads us on to the consolidation. Now, the consolidation you might find a little challenging with it being half term last week, so you've had a break in between your flame tests. However, I would still like you to have a go, give it your best shot. So you've got two scenarios of two unknown compounds. Each compound was analysed. So for compound A, when it was analysed, it gave a yellow flame during a flame test. And when acid was added, a gas was given off at time lime water cloudy. So you've got that scenario, and then you've got scenario B. What I'd like you to do is have a go at applying your learning to those two scenarios. Pause this lesson video, come back to find out the answers. Okay, so scenario A, compound A. Well, if it gave a yellow flame, it must be sodium ion. If it produced a gas when acid was added and the lime water went cloudy, it must be a carbonate ion. The name of the compound, therefore, should be sodium carbonate, and the gas that turned the lime water cloudy, milky, was carbon dioxide. Scenario B, the metal ion, if it gave a green colour in a flame test, it must be copper. The negative ion, well, if a white precipitate was formed when the silver nitrate was added, it must be chloride. Can you name the compound? Well, it must be copper chloride. And the chemical formula, this was a bit of a challenge, CuCl2. Now, the reason for that chemical formula for copper chloride is if you look at the ions, a copper ion has got a charge of +2, a chloride ion's got a charge of just negative. Therefore, to form a compound that has no overall charge, to one copper ion, you need two chloride ions. Therefore, the formula being CuCl2. Right, at the end of the lesson, we always complete our RAG rating for the learning intention. So the learning intention was to be able to describe how to test for and identify non-metal ions. So are you red, are you amber, or are you green? Once you've completed that, please submit your work and thank you for taking the time to complete your home learning.